right, may as well get started. I think my first slides are a little bit intro anyway, and probably most folks know the intro, but I always like to, if I've got time, which I have a little bit of time today, to at least level set on some vocabulary and so on. So we might as well just get started. I'll do a little bit of background on NVMe, and at a storage developers conference, I suppose this is old news. And then take a look at how the concurrent protocols is going to lower risk, which of course is like the title of the talk, right? And then there's some use case discussion and a little bit of a status update on the nature of FC NVMe, and then time for some Q&A. So for the background, of course, NVMe, non-volatile memory express. I mean, it means several things, and I know we at Brocade tend to get a little bit sloppy about it because we got Fibre Channel on the brain. And so within Brocade, and I may do it myself here today, we'll say NVMe when we mean NVMe over Fibre Channel, which of course is one of the fabric options. And then elsewhere, it seems like NVMe can mean other things besides just the sort of basic meaning. It means so many things now. So in terms of a protocol, it's like an alternative to SCSI, right? It's actually a set of standards being overseen by the NVMeexpress.org crowd, which kind of came out of the PCI crowd, and the original spec was really PCIe focused, hence the E. NVMe 1.x is several years old now, much older than NVMe-over-Fabrics, which was published about 15 months ago. 15, 16? No, we're still in September. And NVMe, base NVMe is obviously very widely supported for SSDs and gaining popularity, and it's like the obvious successor to the old, SATA drives and so on. But I'm here, and Brocade is taking advantage of the NVMe over Fabrics spec and movement in that direction, which is a different, a little different use case. What's the benefits? I mean, why are we doing this? NVMe, why replace SCSI with NVMe? SCSI's done such a great job for us, but the big win is mostly what we hear about is in latency. There's a second big win as well, but a lot of it is just in reducing the number of clocks required, and they did this by chucking out a bunch of baggage. Okay, they don't support tape. They're designed more for today's operating systems. It includes queuing, which is overlaid in SCSI and has a lot of overhead to have queuing be separate. And then the fact that it includes queuing makes things more interesting beyond just latency as well. So, I mean, if you look at the stack, one of the AHCI versus NVMe, and of course AHCI is the stack that is where SCSI is inserted. The rectangles are pretty much the same rectangles. Okay, maybe the translation layer is gone, but otherwise it's mostly just that they're smaller rectangles. Essentially that there's more simplicity there. And then the truth is the stack doesn't carve up quite that cleanly. You guys will probably tell me more about that than I can tell you. But when there's context switches, those are very expensive. The enhanced queuing, so in SCSI, it's not built into the protocol in the same way, and so there has to be work done to layer that on the SCSI side, where it's more integrated and it's easier to handle the multiple initiator, which is called a host on the NVMe side, versus target called the subsystem on the NVMe side. And this brings a huge amount of benefits, and well, obviously our initiator side in storage has gotten hugely parallel with the number of cores, the number of threads, and the number of VMs going on just in a single server, and then the number of servers, of course, is exploding. Now, when you had disk drives on the target side, you could get widely parallel up to 100 or something, something on that kind of scale. When you replace spinning disk, spinning media with a piece of silicon, the parallelism opportunities, goes up by an order of magnitude at least, and then each of those pieces of silicon can be more parallelized than a single read-write head or pair of read-write heads. They just don't have as much parallelism available to them. So now we got like massive parallelism on the target side to go along with the massive parallelism on the initiator side, and of course the NVMe folks cleverly decided to do queuing correctly, and that gave big benefits, both in terms of latency, but also in terms of the amount of parallelism. So 64K queues and 64K entries per queue, way beyond what you usually see for SCSI. So here's the three phases. You know, the initial NVMe was really a standardized PCIe interface, as I said before. So we got a bunch of the proprietary interfaces to flash modules, unified them, allowed the market to really go crazy. You know, that's sort of good news, bad news. The commoditization is good for the consumer and for the mass producer. Maybe it's not so good for the the guys trying to differentiate, the folks that are trying to differentiate on their side. But as I said, because the NVMe SSDs became the obvious runner, you know, the one that's going to be the most ubiquitous module around, then the flash array vendors say, you know, how are we going to buy our flash? Do we make our own custom boards, et cetera? It's much cheaper to buy our flash in this SSD format. And that SSD format's PCIe based. Okay, so we have to re-architect our back end to plug PCIe into it. That's not the end of the world. We'll just add that on to our SAS, SATA, maybe fiber channel for some of them. And it's still SCSI on the front side. So moving from here to here uses the same NVMe specification, the NVMe 1.x. No fabric introduction there. It's still speaking SCSI, typically over fiber channel, but it could be iSCSI as well. And then all it is taking advantage of that mass volume produced flash module. Well, then NVMe-over-Fabrics, as I said, that was published 15 months ago. I mean, there was work going on before that. And of course, the fiber channel crowd, along with various folks on the Ethernet side, were diligently working away even before that spec was published, before it was published in final form. But what that does is says, okay, let's not just speak SCSI across the fiber channel or across whatever fabric you've got. Let's speak native NVMe across the fabric, and then you can go right into the device on the back of the flash array. Now, is it possible? I didn't actually even draw these guys down here. So if you look about in terms of evolution, can you upgrade this old flash array to speak NVMe on the backside? Maybe somebody will do that. It's not as well defined. You'd have to do more translation in the flash array. I suspect somebody will try and do that, but we'll have to see whether anybody actually does that, or whether you end up. It's kind of interesting question, which I'll get to later on. If there is no spinning disk in back of such a flash array, et cetera, you know, the ramifications for what that means for your overall SAN architecture if you can't put like tape or spinning disk in back of an array that speaks only NVMe over Fabric. Okay, so what is this NVMe over Fabric again? If you want to have enterprise NVMe, and so this is probably one of these loaded terms, enterprise, it certainly means a lot to me and to Brocadians and our customers. It has a certain, we talk about storage having a service level agreement. We don't really talk about memory having a service level agreement, right? Like memory in this laptop doesn't have any error correction circuitry in it. Most servers do, but the way we think about memory, of course, this isn't, you know, my company doesn't depend this much on this laptop, which I could leave in any airport, of course. Oops. But I've managed to hang on to this one for a while. So we don't overprotect. We don't put too much mission critical stuff on somebody's laptop. You may run mission critical stuff on a server, but there's so many things that can go wrong. You can lose network, you can lose power, you can lose lots of things. There could be a virus, et cetera. So you don't protect compute in the same way. There is a compute SLA. We just include memory into that compute SLA. If there's a single bit error in our memories, right, we correct it. That's what ECC is for, unless it's just a laptop. But if it's a 2-bit error, which they do happen, then you know, you crash the thing and rerun it because you've got a known good image on your storage. And that's because we really protect our storage. You know, 2-bit errors, oh yeah, you got to fix those. You could lose the whole track. You know, we're gonna have a copy of it. Don't worry, you can lose the whole drive. We'll have a copy. Erasure coding or RAID or whatever it is. We invest a lot more in our storage, not on our laptop storage. Not always in our internal server storage, but for sure. And this is what brings us to that enterprise network storage, and what that means really to Brocade and other fiber channel vendors and their customers, is this very very risk-averse kind of way of thinking about storage, because those storage entities versus, say, memory. A memory image, is that a crown jewel? Do we protect memory images? Not the same way, right? There's like multiple copies and you know, it's stored away under a mountain and all this stuff in the case of a vital data asset. And there's other data assets that maybe aren't quite so critical and you don't protect them quite the same way, but there is this class of storage asset, of data asset, that is really requires that high level of attention. And then also you want to have sharing in case that server goes down. Well, another server can do the same function on that data. It can fail over to some other remote data center. It could be just across town or just in another building, or it could be in another continent. Sometimes there's follow the sun algorithms, right? And you're pushing the data around the world. But in any case, that's why you need a network. There's various use cases that really drive you to a networked model versus the PCI, which is kind of sticks you in a server, or maybe allows you to expand to partial rack if you can hook a couple servers up. But if you want to go beyond that, then you have a fabric. And there's the fabric spec I mentioned 15 months ago getting published. It defined 4 fabrics, 2 categories. One of the categories is RDMA. And these 3, Rocky, iWarp, and InfiniBand are RDMA fabrics. And then Fibre Channel is the other category. It's like a category unto itself. And that's because I think the RDMA guys, well, RDMA really came into its own with InfiniBand, which is maybe 15, 18 years old. A little bit younger than Fibre Channel, is about 20 years old, or maybe a little more than that. And the InfiniBand guys are kind of like super, PCI on steroids in a way. It was like clustering technology. And they said, hey, you should use RDMA for across Ethernet. And that, anyway, it kind of kept going. And you should use RDMA across Fibre Channel, which we didn't have. Fibre Channel is still currently looking at doing RDMA. But RDMA is more of a server clustering protocol, and Fibre Channel is very storage-centric. So we'll see whether that takes off. But what ended up happening, we looked at doing RDMA over Fibre Channel and said, boy, that would be a lot of work, and it would actually make it more difficult to run SCSI and NVMe in the same SAN. It would make the ASICs more expensive. It would require lots of investment. So we said, we can run them both together if we stick with the same model we did before. So we're just going to run NVMe natively on top of Fibre Channel. We'll leverage the same transport we use for SCSI, for FCP. FCP is a little bit of a blurry term in Fibre Channel, and even the experts will argue about what exactly FCP means. But with NVMe, we leverage the transport layers, the same transport layers we use for SCSI. And so it was a very straightforward implementation, which is a win as we get to later on in the ability to use dual protocol. A win partly for the vendors, but turns out to be beneficial for the enterprise storage customers as well. So as I mentioned, these 3 do RDMA. NVMe just as NVMe-over-Fibre Channel is native. Recently, our sort of the other guys said they're going to support NVMe over Fibre Channel, and they also want to support it over FCOE. Well, because FCOE is just Fibre Channel over Ethernet. If it runs on Fibre Channel, it'll run over FCOE. So sure, it's not described, it's not defined in the NVMe-over-Fabrics spec, but it kind of doesn't really need to be. So implicitly, if this works, then this should work. I don't know if this is part of like UNH Plugfest. So that would be one like small difference, but otherwise FCOE should work. iNVMe, that's our nickname, Brocade's nickname for NVMe over TCP, which when it's abbreviated, I think they now prefer NVMe dot or dash TCP. So they just leave out the over. It's kind of odd when there's an O or when there's not an O, but anyway. NVMe over TCP is a lot like iSCSI over TCP. I mean SCSI over TCP, which is called iSCSI. So then we decided to call it iNVMe because it's very parallel. And NVMe over TCP is not RDMA based. That's good to remember because a lot of times it seemed like even though that was in the spec that there's Fibre Channel and RDMA, it seems like a lot of the advocates of RDMA sort of treat RDMA like it's a synonym for the fabric. Well, there's 2 kinds of fabrics, and this is another non-RDMA version. This is being, it says up there, it was really Facebook that came forward and said that. And the reason is, well, mostly not, InfiniBand is mostly for high performance computing, and there's some constraints with InfiniBand. That probably wasn't going to be really widespread. And so most of the focus has been on RoCE and iWarp over Ethernet or over Fibre Channel. And what I was going to say is RoCE and iWarp both require an RNIC, an RDMA-enabled NIC, on the server side, or on target side for that matter, in order to really give you the speed. In theory, you could run it in software, but it's not going to be fast. So if you want to have the speed of NVMe, then you need an RNIC in order to run RoCE and iWarp. Well, guess what? Facebook has massive data centers that don't have RNICs in them, and they said, look, we're running iSCSI now, why can't we just run, maybe they even called it that, maybe they even called it iNVMe, but they said, we just want to use our existing commodity infrastructure, which is basically why people use iSCSI now. It's not that it's faster than Fibre Channel, but it's commodity. So they can use their existing network. Maybe they make a dedicated network, but either way, whether it's a dedicated Ethernet network or a shared network, they can use their commodity infrastructure, commodity servers, the NIC that's on the motherboard. It's not a special NIC, it's not a TOE, or if it's a TOE, it's a commodity TOE, right? TOE being TCP offload engine. That's sort of like old speak. In any case, Facebook stepped forward and said, we'd like to do this because basically they were not, these options didn't, none of them really did what they were looking for, which makes sense. So, and then Intel and I believe it's Dell EMC are on board with Facebook and working this forward. And that was, I think, I first heard about it in March, I think. And they've been making steady progress and they keep talking about it. And what's interesting about that, as I say, is it's not RDMA. So if you start hearing people say, oh, well, you really need RDMA because NVMe needs RDMA. Well, NVMe, the basic PCI version, doesn't use RDMA, and this version doesn't, and this version doesn't. So there's nothing inherently requiring RDMA in NVMe. But those are the several fabrics. It does, if you're using Fibre Channel, you got the Fibre Channel choice. If you're using Ethernet, there's still sort of a VHS versus Betamax kind of problem going on there. I think that'll sort itself out. I think it'll end up being iNVMe for the same reasons iSCSI took off. Okay, reducing risk accelerates adoption, right? So like I said, we have these enterprise storage customers that their job is to protect their high-value data assets. And then probably they protect some other data assets that are not so high value, and those storage teams are, well, the nature of risk-averse teams is they're probably a little careful, and so I think for certain groups in an enterprise, they want to have the flexibility to spin something up and spin it down and re-architect it. Those are the guys that are saying, look, we'd rather do stuff by ourselves and we'll manage our own storage, but and we'll take responsibility if it gets lost, all right? So I do think that there's been some folks that they were originally using the enterprise storage team to take care of a data asset that wasn't as high value, and now they're looking at other architectures for that. But there are still a great number, and you see this in the explosive growth of enterprise flash arrays. Those are 80%, 90% connected to Fibre Channel. Those, and they're very powerful, and they're very they have high availability, high SLAs. So anyway, yeah, we got these risk-averse teams, and now they're looking at, well, in fact, I'll share with you at the end if you haven't already seen it. I co-wrote a book called NVMe over Fibre Channel for Dummies, and we were pushed by our customers to do that because they had seen that NVMe over Fabrics spec online a year or more ago, and they heard all this noise coming out about the RDMA protocols, the RDMA options, and usually Brocade tends, and the other SAN vendors, the other infrastructure vendors tend to defer to the storage vendors in terms of messaging, but the storage vendors weren't talking a lot about it, in part because storage vendors are, like their customers, a little bit conservative compared to the aggressive sort of server-side stuff. So anyway, we came out with that book, and most of it is to say, look, we're still doing this. We are doing fiber channel and FC NVMe. And so basically your future is safe with fiber channel, and that's what they really were looking to hear. So, and that's some of what we're talking about here as well. In order to get them to adopt NVMe, those conservative folks, they need to know that they can adopt it without putting their high-value data assets at risk, right? They know that any downtime or data loss can mean a really big OpEx problem. I mean, you know, that's the $1 million a minute or, you know, hour or whatever it is. It's just, it ends up paying for the equipment very quickly if you have any kind of significant downtime. And those are the kind of storage assets that you need really high performance access to it, because you got to scale out to internet scales or scale up to internet scales, however you want to think about it. And so it needs to be very fast, and also it's super important, so you got to protect the hell out of it. And so these teams, they have to plan ahead in order to avoid this risk, and that's what they're looking out 2-3 years. Okay, well, I don't need NVMe tomorrow. In fact, I can't even buy it in terms of NVMe enterprise NVMe arrays. They could buy, like I said, phase 2, where the NVMe is in the back end, but NVMe-over-Fabrics, they're looking out and they're saying, okay, I can't buy that yet. None of my vendors, my usual vendors, are offering that, but I know it's coming. I mean, it's faster, it's more parallel. The world's going to go to NVMe over Fabrics. Which is it? Is it going to be Ethernet? So this is why they're calling us up and saying, tell us about the fiber channel option. Otherwise, I have to start educating all my teams about whole new tools and whole new infrastructures, et cetera, which I'll talk more about. So then they're trying to figure out, is my world going to end as I know it, or can I like dig in and stick with SCSI, and maybe we'll just use NVMe on the back end. And anyway, lots of nervousness and lots of phone calls and emails that generated this, the Dummies book that I mentioned, which you'll be able to download. I could have brought some. Celeste, did we bring any books? Oh, good. Okay, good. You guys have heard of the FCIA? They can be. They can be. Yeah, I'm not going anywhere afterwards, so. And yeah, I've done it before. So anyway, if there isn't a low risk adoption model, then a whole bunch of folks will stick with SCSI. That's just, you know, how they're wired, and then they may go try the other option in some lab for 3 or 4 years until they've decided that it's really safe. Because as I'll show you, the adoption operations are much more complex if you don't have dual protocol. And then on the flip side, you know, if you make it easy and you make it safe, and you reduce both the sort of real and perceived risks, because, I mean, what I would say a perceived risk would be a technology that you don't know. That just feels risky, right? What's involved there? So Fiber Channel is the premium fabric, and sometimes I feel a little funny saying that. I mean, it seems sort of snotty or something. But it is. It's a little more expensive. It was born in Ethernet. I was working at Bay Networks at the time. I just saw my boss from Bay Networks out in the lab, Martin White. He's at Cavium now, not doing fiber channel, even though Cavium now does fiber channel. But it was fun to flash back to that. And we had some people leave Bay Networks and go join these fiber channel startups, and I thought, you guys are crazy, right? Because back then, Ethernet was crushing token ring. It was crushing ATM. Why did fiber channel think it was going to be any different? And it's because it was aimed at a premium market, or very quickly it was. I mean, they pivoted, as you would say, in startup space. And they became focused on the use case that needed speed and needed very high reliability. And it's quite adapted. It's got a number of features. It's got, you know, buffer credit, flow control management, right? It's got fabric-based services, a lot more interoperable. It has a smaller market, right? So it doesn't have as many vendors climbing in there. And the good news is that means the storage vendors can do full matrix testing, right? They'll sell you any brand of network, they'll sell you the HBAs, and they've tested with all these things so that when a phone call comes in on the support line, whether they sold that array or that HBA or not, they know how it works. They understand how it works. And the buffer credit model is a much more robust, and I mean InfiniBand itself uses buffer credits as well. That's basically kind of a grown-up version of how you do flow control versus Ethernet, of course, at the beginning didn't even do flow control on a point-to-point basis, and IP does it, or TCP does it on an end-to-end basis. So anyway, Fibre Channel, it's this premium fabric, and you get what you pay for a little bit, right? There's this robust culture in enterprise storage that knows how to take advantage of the aspects of Fibre Channel. And a lot of I say most storage environments are brownfield. We certainly see that. There's a lot of, if you talk about terabytes, that's true. If you talk about number of efforts, maybe there's a lot more little brownfield things that are just a gleam in someone's eye in the lab, and they're spinning something up. And so replicating this massive enterprise environment is painful and expensive, and it requires lots of, if you're replicating it exactly as you currently know it, even that's a little bit expensive, right? But it's not as painful as if you're changing protocols, you're changing a set of tools, and everything becomes different, and now you got to toggle between, do you have two teams, or do you have, and then when you're doing migrations, who's responsible, et cetera. So for performance and visibility, and that's one thing I skipped past a little bit, the other thing we have in Fibre Channel is because it's storage focused, we can invest some circuitry in our ASICs that's very storage focused toward visibility. And so it lets you see in there and have visibility into IOs, IO latency, level of traffic. There's just lots of visibility hooks we can put in there. In Ethernet, that's difficult. The Ethernet IP, there's hundreds or thousands of applications, and how do you invest in one application and not in some other application? There's simple counters for basic things, but we can do more in Fibre Channel. And I mentioned the fabric services, and all of this allows us, in part because we decided not to do RDMA, but to just run NVMe natively over Fibre Channel, we can leverage all this. And that reduces a bunch of risk. So here we have a picture of a kind of a dual protocol SAN, dual protocol storage area network. It can run on, so Brocade and some of the other vendors call 16 gigabit Fibre Channel Gen 5. I've been informed the FCIA doesn't call it Gen 5. They didn't adopt that model until Gen 6. Like I said, the storage people were conservative. So, this is 16G for those of you who haven't seen Gen 5 before. I think you probably figured that out. Anyway, for both of the main vendors of the SAN equipment, both of the speeds, the 16 gig and the 32 gig will support NVMe over Fibre Channel. I can't remember exactly when we announced it, probably about a year ago, and the other guys have announced it earlier this year. No real big surprises there. On the HBA side, on the adapter side, they're pretty much saying, well, they need to use the latest silicon for that. They may call it something else like QCavium. They'll have enhanced Gen 5, which is a Gen 6 ASIC with a cheaper optic adapter. Broadcom, if you say Gen 5, you actually get some old silicon, but I think they're going to end of life that silicon within the next few months. They say, today, if you try to buy something from QLogic, what you buy will run NVMe unless you find some distributor out in the weeds that has some old Gen 5 thing. Today, it's still possible to buy an HBA from Broadcom or Emulex that doesn't support it, but very soon that'll become difficult. And so essentially, if you're building a SAN today, you're probably building an NVMe-capable SAN, whether you intended to or not, and the products aren't even available yet, right? If you wanted to make a change, you have a Gen 5 fabric and you got a server and it's got a Gen 5 adapter. Well, changing out a HBA is not a major effort, right? It's something storage teams have upgraded the speed of an HBA on a regular basis. This is not a highly disruptive upgrade. And it's much less disruptive upgrading a single server than upgrading your SAN. So we encourage the customers, you probably want Gen 6. If you're so into speed that you want NVMe, you probably want a faster fabric because this is going to lower your overall I/O latency, even if like switching speeds are sub-microsecond in either case. It's not, even with flash, we're not looking at where 1 microsecond is making a huge difference, although I think in a year or two we will, yeah.
Is there any specific FOSS version required for that?
Of course, yeah, there's newer FOSS versions. The big difference is the name server has some little differences in it. So there'll be, I think, FOSS 8.2. I think it's FOSS 8.2 for this and FOSS 8.1 for that. But yeah. So what I was saying is that you can get familiar with NVMe over Fibre Channel using an existing Gen 5 fabric. Probably would run on Gen 4 as well. But if you think about it, we do these massive test efforts, and we're not going to go invest a lot in Gen 4 when we're not selling Gen 4. Why would we do that? And why nobody would buy it anyway, right? Same thing. If they're interested in the speed of NVMe, why would they be running Gen 4? So it makes sense for us to do Gen 5 and Gen 6. And then similar logic on the HBA side. In fact, it's more work for them. This took some work on our part. We added some additional counters in Gen 6. So I mentioned that visibility that we have, the ability to see in and understand what's going on in your fabric. That's better in Gen 6 than it was in Gen 5 for NVMe. And so there's motivations to move to Gen 6, but you can certainly get acquainted and come up the learning curve on a Gen 5 array, and you'll probably need Gen 5 or Gen 6 HBAs, or at least the silicon piece of it. The optic could be Gen 5. Could even be slower than that. Yeah.
So would this automatically redrive an I/O that failed due to fabric on that protocol?
The first NVMe, FC NVMe 1, they don't call it 1, but FC NVMe, the standard, which I'll touch on, has the same error handling as FC SCSI does. So it does have some retries. They're looking at doing some better I/O or better error handling in FC NVMe 2, which is in the very early stages. So, but FC NVMe is parallel to FC SCSI, FCP.
So the committed write would still find an available protocol, even if one protocol.
Oh, it doesn't switch protocols dynamically. So a given volume will be mapped to a NVMe or a SCSI target. And so if it was SCSI on the first try, it'll be SCSI on the second try. And if it was NVMe on the first try, it'll be NVMe on the second try. It won't, yeah, it's not quite that dynamic. It's pretty dynamic, but you have to reconfigure the mapping on the host side to get the other target, the other line.
So what happens in the event there's a failure on, let's say an I/O is directed through the infrastructure for NVMe and winds up being transported by that protocol and it fails because of the protocol. What happens at that point to the I/O?
Well, it's hard for me to interpret what you mean by fails because of the protocol. In order for you to even begin an I/O, you would have had to go through a login process, and so if the protocol wasn't there, you would fail the login. And so an I/O wouldn't fail because of protocol purposes, unless somebody pulled the cable, but that's not really a protocol issue. So if you had protocol compatibility issues, that should be found out in the login phase and discovery phase and so on, which is not the normal part of FCP, FC SCSI already. And that's actually one of those things where we get to leverage the fabric services again as we newer specs for fabric services. Now when the target device registers with the fabric, it signals that it speaks which protocol it speaks. And technically it can, like in this picture, it can say it speaks both. Our expectation is probably most targets will speak one or the other, target ports I should say will speak one or the other. Probably not, if we sort of hope so. I think that would be a best practice, but maybe it might be able to speak both, but you might only turn one on or the other. I've kind of gotten a little adrift of your question, I think. Am I getting around what?
Well, the point is if we're telling the user by running concurrent disparate fabrics, right, in order to reach your SLA, that's the point. We're going to run NVMe and Fibre Channel.
Yeah, I wouldn't recommend that you have the same volume be mirrored on two different technologies.
Are we mapping everything over
But you can
mapping this set of volumes to the NVMe side and that set of volumes to
exactly. That's much more the model, and I was getting to that.
Okay, I'm sorry, I didn't mean to jump ahead.
No, that's fine. Keep me honest.
Okay.
And I think it's interesting because this is a good sized room so people can interactively, and I don't know, culturally, you guys are willing to do that. I'm glad. I should have invited it, but I get so used to it, I invite it and then nobody raises their hand until the Q&A time. But I like the discussion model. So yeah, I'll go forward. I think the next slide talks a little bit more about migrations. As it says here, you can read the bullets right, but if you have a server, either of these servers can both the HBA vendors, I'll say, make a big deal out of this, that they run both protocols on the same wire, the same HBA, the same stack, and both of them realize that this is essentially the key value add of Fibre Channel is this ability to kind of work the old way and work the new way at the same time. And that lowers the risk, as I was talking about, right? So you run it over this same infrastructure, and probably it's a different target, or it could be the same target but a different port. As I was saying before, I could believe that somebody will make you a port that'll work both ways, but one of the things that we're looking at is that there is likely going to be a desire or a best practice to run the traffic on different links, and so maybe I just need to take my drawing and move that link over to the other port that's not really depicted there, right? But anyway, it runs on the same server, same HBA, same fiber, same SAN, typically dual SAN, although it'd be weird that you would run one speed and one the other, a little bit of artistic license there. Same fabric services though, FC NVMe, so you go to Discover and you can say, okay, when you figure out that there's a target out there, what does it speak? It'll probably speak one or the other. In terms of the spec, it's allowed to speak both, but it'll probably speak one or the other, register as one or the other. And otherwise, same management tools and diagnostic tools, et cetera. Then I mentioned already the full matrix testing that you get in that ecosystem that you don't get other places. And sort of the same notion about what we mean when we say enterprise, or when the phone rings, it means I need it fixed yesterday kind of thing. Not, yeah, well, can you send somebody out or point me to the manual page? I already looked at the manual page. Okay. This is where I was talking about the migration. So you can migrate volume by volume very often for complicated applications. What's an application? Is it a piece of software? Is it several pieces of software? It varies by, that's another one where the terminology is kind of overloaded. But typically there's a group of volumes that move together in terms of a sort of meta application. And you can migrate those one by one in an infrastructure like this. And they may not all have the same service level agreement needs, right? You may have one that, like your log files, okay, I really do like to have those and have it, but if I lost them, my boss might never even find out. Versus if you lose the database, everybody in the company is going to know about it. So you have different volumes with different SLAs, and they may have different speed needs as well. So maybe you say, well, okay, I've got my log, for example, my log volume. I'd love it if it ran a little bit faster, and I don't care too much about the SLA, so let me just try that one first. I'll move that one off of my SCSI array onto my NVMe array, and I can do that on a Saturday morning, or I could do it late at night. I don't have to book a 3-day weekend because I'm only moving one volume. And the rollback model is very easy to understand, and storage teams don't move their volumes they don't migrate a volume unless they know the rollback model. And in a case where you're using the same infrastructure, the model is very straightforward. You sort of take down the app, copy it. Sometimes you can copy the app live, or copy the volume live, and then you do the migration fairly quickly. And then if it didn't work, then you just remap it back, done, right? In the model where you have two separate infrastructures, separate sets of servers, the other servers got RNICs in them, it's now Ethernet, fabric, et cetera. It's a completely different architecture. I mean, it's for sure different pieces of hardware. Picking up that meta application with its dozen volumes or however many volumes it is, and moving it over there, that's a complex process that takes, they go through lots of testing in the labs and take lots of care, and they validate, and then they wonder about what's their rollback model going to look like. Suppose it comes up and it's not running right, and this happens hours before, the sun comes up on Monday morning. Oh my God. So that rollback model, you have to work through that very carefully. You got to spin it all up and make sure you remap all the, IP addresses back to the original servers, et cetera, whatever, if that happens, right? So the model of moving a volume, okay, I moved one volume, that worked fine. And we've demoed this with, first we take servers, because there haven't been any FC NVMe arrays or very many NVMe-over-Fabric arrays of any kind until just recently. But you take a server and you put the HBA in target mode and you put it down there, and we've been able to run with these pseudo targets for for actually 18 months or something. So our recent demos have done this where we take and we speak fiber channel and we speak FC SCSI and FC NVMe using the same application to two different volumes, one on SCSI array and one on an NVMe array. It's very straightforward. Storage teams look at that, they nod their head, it makes sense, it's comparable to changing speeds, or just migrating to a new vendor of an array, which they've done many times. You got vendor E here and vendor H there, and you just buy a new array and you can move to that new array. There's no surprises in that model. It fits right into their worldview. And this allows them to say, okay, I'm going to go buy this thing. I understand how that works. We'll bring one in, we'll do some trial, and basically you don't have to educate me. I don't need to learn new apps. I don't need to learn new protocols. That's not completely true. There will be some differences for NVMe over Fabrics, but I only need to learn one more protocol, the NVMe protocol, and not these other protocols as well, and not other operations models, not other models for that. And I don't have to operate with my old one and my new one. And what's interesting is it kind of feels like, there's going to be this migration from SCSI to NVMe and like it's an event. When we talk about migrating a volume, that's kind of an event. We'll migrate a volume over the weekend or some evening, whatever. But in this migration from SCSI to NVMe, that's really more of a process. It's going to take years, right? It's going to probably take longer than it took to migrate from spinning disk to flash. That was one that mostly that migration can happen behind the scenes on the back of the array, and the end user, they kind of care. I mean, they want to get comfortable with it and so on, but by and large, that was one that they could do fairly quickly. And most of our customers have flash, and most of our customers also still have spinning disks, so they're not going to turn those off instantly. And so if you go back and look at that other picture, or I can pop us back to that other picture, and she came in and said I had 10 minutes. So in this picture, no spinning disks down here, no tape. Well, if you're going to have spinning disk or tape around, that means you probably speak in SCSI. And so as long as there's going to be spinning disk around or tape around, you're probably going to be speaking SCSI, and that means you're going to have a SCSI infrastructure. Does that mean you have two infrastructures over a 5 or a 10-year transition time frame? So this is one reason why they're just much more comfortable. You can't even tell them what day, right? It's not just that it'll take a period of time. You don't know when it's going to end, right? This is going to be a long, gradual transition, and so the ability to do that on a dual protocol environment, single infrastructure, familiar tools, familiar services, et cetera, familiar vendors to some degree. There'll be new vendors. I mean, that's healthy too for the environment, right? To change out vendors, maybe even here too. We should be honest about that. But the NVMe over Fibre Channel coexisting with NVMe or with SCSI over Fibre Channel is really powerful. One of the things I was saying, and maybe you guys are familiar with this, with the storage team, when they do a big migration versus a small migration, they need to book a 3-day weekend. And if you've got a large number of like meta apps, that means you've booked out your three-day weekends for the rest of the year. And they want to use those 3-day weekends for other things too, not just going to the river, but it seems fair enough that they should be able to go to the river once in a while. But they want to use that also for other infrastructure changes that they need to do. So this one's looking at the use cases, and for the most part, early on, it's the same use cases that you've seen before in SCSI. It's just that they're more latency focused, or potentially more IOPS focused. But that's not a re-architecture, right? You just kind of do the same thing. In the IOPS case, it's what I said before. Lots more parallelism on the server side. That's not new. That's been happening before. This isn't really new either, in the sense that we've been moving to flash on the storage side for a long time, and it leaves much more room for parallelism. Now we have a kind of a protocol architecture that allows us to take real advantage of that highly parallel environment, and not essentially, if SCSI queue depth has ever been a problem, that will no longer be a problem with, assuming that they, that the vendors architect their arrays to take advantage of that. But if they're competitive, they will architect their arrays to take advantage of that. Now, one thing I wanted to mention is, of course, you do our new apps that may require more performance, less latency, but they don't really care about SLA. And here I'm sort of assuming that, okay, the original implementations on NVMe, especially if it's NVMe straight through, are going to be less feature focused. And with fewer features, you don't necessarily put your crown jewels on that app. So it might be it's a data mining app, and this might be a reference database or a reference data asset as opposed to the master copy. Well, that actually leads to another use case, and that is by having this all in the same infrastructure, you can have your live master copy. It may be running on your old trusted, tried and true SCSI array, and it has the ability to do snapshots. It's got this great SLA. It's maybe even replicating somewhere else. It's not shown here. But you take a snapshot of that and you copy it over to your higher speed NVMe subsystem so that then you can crunch the hell out of it at really low latency. And you can do all that on the same infrastructure. And you've got an app over there that speaks both SCSI to the old array, so it can grab the snapshot and copy it over here, but it also speaks NVMe. So these kind of hybrid use cases are attractive as well. That's also difficult to do on a single protocol model. Get through this as quick as I can, just in case there's a few more questions. So T11 approved FC NVMe spec. I mean, they sent it out for letter ballot in December. They got all their comments back, integrated it in, blessed it in August. T11 is part of Insights. Maybe I should be saying T11.3 and T11 something else. I get the names of the I get sloppy with the names of the approval boards. But in any case, they should bless that. I think they're going to send it in October, and they'll bless it soon. It's rare that the higher level body rocks the boat by making a change. The first UNH Plug Fest for NVMe-over-Fabrics was in June. 12 participants. The next one will be next month. And other plug fests are happening on a regular basis. This is a picture of the FCIA demo rack at a recent event, but also just something we do offline. Lots of players involved. And then this one over here is the interoperability fabric that was at UNH back in June. There's a lot of the vendors are now starting to talk about it, and as I said, these guys are a little bit conservative, so anytime somebody says something, it's, oh wow, did you hear what they said? All right, and recap. Since I'm a little short on time, and since I just said all this stuff, I partly put this here so when you get the slides, it's useful. And then there's the more interesting one. This is the front and back cover. That's what the new dummies guy looks like if you haven't seen this in a while. Yeah?
I got a question.
That's not me.
You've got kind of a hybrid infrastructure in place. Some of the high latency, tight SLA type applications, do you think there's a possibility that they suffer from zero buffer credit issues if you've got slow drain devices or even
Absolutely. I mean,
misbehaving?
that's true even in SCSI, right? And in the, I'm sorry?
Would you recommend port fencing while you've got this hybrid, or is there another strategy for the?
Yeah, there's probably, I mean, it's a little early for us to really come forward with full best practices, but I expect exactly as you suggest that those will be best practices that you'll see. In fact, sometimes they'll say, well, you know what, you shouldn't have anything older than Gen 5 on there. I mean, and of course you could have Gen 5 HBAs, but if you run it at a slower speed, that doesn't really solve it. So I think you're going to be seeing things like that there'll be best practices that restrict so you don't have those slugs. Now, as it turns out, though, one of the differences that I didn't mention, so right, we talk about latency, we talk about IOPS, we didn't talk about bandwidth, and a lot of it is about bandwidth when you talk about flow in a fabric. The flow in the fabric, we get high bandwidth in SCSI too, partly because we have tons of spindles or because we have lots of cache or something like that. So I think we need to go through the process of running these things, but I don't think it's going to be radically different. maybe you will see, as we just talked about, something that used to be able to get away with 100 microseconds of jitter in its latency. That's a lot of jitter on 100 microsecond. Oh, out of time. Come by the booth. Most of what I said is in the book. And I'll be out the door, so you can ask me questions out the door. I'm sorry I didn't give you enough time for more questions today. Thank you.